Hello and welcome back to representation of numbers. So today we're going to look at character codes. So you need to understand how characters are represented using ASCII, which is American Standard Code 2. Okay, so we're going to understand the purpose of ASCII and Unicode, and then you're going to convert characters to code and decode messages using ASCII and Unicode. Well, mostly ASCII really. So what is ASCII? So it stands for American Standard Code. And we know computers, as we discussed last lesson, just simply can read ones and zeros. So I just know ones and zeros, and that is pretty much it. But these ones and zeros have various representations for different reasons. So they could be represented into different languages, such as binary, some ASCII, binary coded decimals, machine code, and so on. And it's all ones and zeros that are just interpreted in various different ways. So we already know that we can convert binary to binary, and then there's hexadecimal numbers as well, which we'll go through another lesson. But what about the characters? Okay, so the characters that are on your keyboard. So if you take a look at your keyboard right now, there's various keys. So we've got the, the A's, B's, C's and D's. We've got letters. You've probably got a Windows key or an Apple key. We've got a space bar. We've got a caps lock. We've got a shift key. We've got number keys. We've got the num lock. We've got the keys with the operators of divide, times and add. We've got the enter key. So we've got all these different keys. We've got the F keys as well. So, the function keys, F1, F2 and so on. So how do they get converted into something a computer understands? Because the computer needs to understand what we're doing. Okay, so now all these characters are represented as numbers. Okay, so every single letter and symbol on your keyboard is assigned a number. Okay, so for example, and they're also assigned numbers for uppercase and lowercase. They've got different numbers. Okay, so like uppercase A is the letter is number 65. So now you're going to have a copy of this ASCII table, but you can see here, okay, that every symbol has got a different number. So if you take a look at the @ symbol, it's number 64. And as we said earlier, number 65 is A. Then if you look at lowercase a, it's number 97. Okay, so they've all been assigned different numbers. So now from ASCII to binary, so the ASCII has to be converted to binary. So ASCII is 7 and has a maximum of 127 different numbers. Okay, now we can represent all the cases and uppercases, the lowercase and the uppercase and the symbols and the digits, as well as commands such as backspace, which is A, and escape, which is number 27. Okay, but the disadvantages is that we are limited to 127 characters. And some languages are not represented in ASCII at all. Okay, so if we take a look at the Greek alphabet, the Armenian and the Hebrew and the Arabic alphabet, they can't be represented in ASCII because of how many symbols they have in their alphabet. So if we look at Unicode, okay, so Unicode is the same as ASCII, but it's got more bits. Okay, so it can include all of the alphabets. Okay, so as you can see here, so there's some different alphabets here, and a wide range of symbols. Okay, now thanks to Unicode, we have an ever-growing use of emojis. Okay, so the emojis just basically started out as a happy face and a sad face. Now we've got loads and loads of different ones. Okay, so like you can see some popular ones here, like hearts that come in all different colors and so on. So ASCII versus Unicode. Let's take a look at this. Now ASCII is a 7-bit code. Okay, so that means it can represent, up to 127. Now Unicode is the same as ASCII, and it does go from 0 to 127. But ASCII can be extended to 8 bits. Now Unicode can be 8 bits, 16 bits, or 32 bits. Okay, so Extended ASCII is 8-bit, so it's got a bit more, but then Unicode has so much more. So 32 bits can give us this number of characters, okay? So that is a rather large number. Now, what I'd like you to do is you're going to decode some facts. So like, I'm going to give you some facts here. Like, for example, the letter Q does appear in a US state, but X only appears for New Mexico and Texas. Okay, so that's fairly interesting. Right, now I'm just going to share my new screen with you. So what you'll find under this video and on Google Classrooms is you've got the ASCII table here to help you convert. Okay, so using this ASCII table, you are going to complete this worksheet. Okay, again, that is underneath here. Okay, so underneath the video and on Google Classrooms. So using the ASCII table, I'd like you to decode the facts word by word. So this is one word, you can just type it underneath. So it's all you've got to do is write, okay, number 84. Number 84 is a T. So there's a T. Number 104. So we look for number 104 and it's an H. Okay, so I think you get the drift, sorry, lowercase h. So I think you understand what's going on here, okay? Right, then once you've done that, you're going to research and find the ASCII code for a blank space. So how is a blank space represented in ASCII? Then once you've done that, you're going to decode this fact. And as you can see, there are no spaces because you've got to find the ASCII code for the blank space. So here you've got a table to help you out, but here you've got all the facts at once and you've got to find the ASCII code for the blank space. Okay, right, so enjoy it. Now you will find these two sheets on Google Classrooms or click on the link underneath this video. Very best of luck to you.